This is an interesting problem in conservation of energy. Let us see the problem. A sledder starting from rest slides down a 10-meter high hill. At the bottom of the hill is a long horizontal patch of rough snow. The hill is nearly frictionless, but the coefficient of friction between the sled and the rough snow is at the bottom is mu k is equal to 0.30. How far will the sled slide along the rough patch? Okay, what he is saying is here, a sledder is sliding across the frictionless ice. Okay, but at the bottom there is some rough patch. That means that the ice is some rough patch which is causing the friction. Okay, now we have to find out on this rough patch how far the sledder can slide. Okay, that means here what we have to do is we have to take the entire system as isolated. Okay, suppose if we take entire system as isolated, then the total energy of the system is conserved. Okay, initially the slider has the potential energy. Okay, see here the slider has only potential energy, and then while sliding across the rough patch, the slider has thermal energy. Okay, why thermal energy? Thermal energy is produced because of the work done by the friction. Okay, so we have to equate these two. There are no other energies beyond that. Okay, because once it comes to a stop, then there will be no kinetic energy, and then it is coming down and then reaching the bottom of the hill. Okay, so that is why the gravitational potential energy will also become zero. So initially the object has only the gravitational potential energy UGI that must be equal to thermal energy. Okay, as we are considering the entire system as the isolated system, so the work done by the frictional forces converts into thermal energy. That thermal energy must be equal to this one. So the law of conservation of energy satisfies. Okay, now how to find out the thermal energy? So thermal energy is equal to, we know, work energy theorem, W is equal to delta E. So here E is the change in thermal energy. Initially it has no thermal energy, zero, because the slider is sliding from rest. So therefore there is no thermal energy. Moreover, here entire slope is frictionless. Only at the bottom they have some rough patch. That is why here there are no frictional forces. No work is done by the frictional forces. Therefore, there is no thermal energy. Therefore, zero thermal energy. Only here we have the thermal energy. Okay. So therefore, we have to equate work done by the frictional forces. Work done, W is the work done by friction. Friction is the non-conservative force. Therefore, we will get the thermal energy. Now, we know friction is equal to F friction is equal to mu Fn. But what is Fn? That we will find out from the force diagram. Suppose let us consider this be the rough patch, and then here is the object. Then the Fg acts vertically downwards and Fn acts vertically upwards. And then if we write the force equation, sigma Fy is equal to ma. And then A is equal to 0 because there is no motion along the vertical direction. And then sigma Fy is equal to Fn minus Fg is equal to 0. Therefore, Fn is equal to Fg, and then Fg is equal to mg. Okay, here, therefore, we can substitute F friction is equal to mu k times mg. Okay, and then we know UG is equal to mgh. Okay, let us substitute the values here. mgh is equal to mu k mg. Okay, so mg goes off, and then mu k mg, this is the friction, and then work done is equal to F friction times d. So this is equal to mu k mg times d. Okay, so I will write mu k mg dot d. Okay, mg goes off. We are left with h is equal to mu k times d. mg goes off. Okay, therefore d is equal to h by mu k. And then we know h is equal to 10 meters. And then mu k is 0.30. Therefore d is equal to 10 by 0.3 is 33 meters. So 33 meters is the distance the sledder is traveling along the rough patch before coming to the rest. That is the answer for the problem. Hope this helps. Thank you. Bye-bye.